Okay, so in this video, we'll be going over the quiz that we just had, the most recent one, quiz 29. So pKb of Cn is 2.5, and our goal is to calculate the pH of a 1.88 molar HCN solution. So what we should first do is identify bases, acids, weak, strong. So Cn is a weak base, and Cn is the strong, or sorry, not strong, weak acid that goes along with it. We know that this is weak because there are only 6 strong acids, and it is not one of them, so therefore it has to be weak. And the conjugate of that is a weak base. The only strong bases are really OH. Okay, so now we notice that our pKb is 10.5. So we have to convert this to a Ka. So how do we do that? We can do 14 minus 10.5, and this becomes 14 minus 10.5, 3.5. So 3.5 is our pKa. And how do we convert pKa to a Ka? It's just 10 to the negative 3.5. 10 to the negative 3.5 is 3.16 times 10 to the negative 4. So now that is our Ka. Now with that, we can set up the equation. So we have to calculate the pH of a 1.88 molar HCN. So what we just do, how do we set this up? So we start with HCN. So HCN plus, what is it always plus? It's always adding with water. Goes to equilibrium. It is not 100%, and what it becomes is H3O, because this H goes to here to form H3O plus, and then what's left right here, Cn minus plus Cn minus, the weak base. And we are given 1.88 molar, so our ice table, 1.88. H3O plus, we can just do 0, and Cn minus is just 0. So our Q is less than Ka. So that means we go to our product side. So this is minus x, this is dash, this is plus x, this is plus x. We know how to do the ice table. Now we have our Ka that we use. So 3.16 times 10 to the negative 4 equals the product of reactants, x times x over 1.88 minus x. And let's use our numeric solver. Math numeric solver. We got 3.16 times 10 to the negative 4, and this is x times x over 1.88 minus x. Boom, alpha solve. Our x equals 0.0242. So now, how do we find pH? Is we just find the negative log of the concentration of H3O plus. So H3O plus concentration equals just x, 0.0242. How do we find concentration? Negative log of that, 0.0242. What does that come out to be? Negative log of 0.0242. What do we get? 1.62. That's our answer. So the next question of the quiz was, we have 144.2 milliliters of 2.66 molar of lithium BRO is mixed with 12.1 milliliters of 1.03 HBRO. And the Kb for BRO minus is 4.03 times 10 to the negative 6, and the goal is to calculate the pH. So what we can first identify is strong, weak, or whatever. So let's start with the acid. So HBRO, we know that it's not one of the 6 strong acids, so therefore it has to be a weak acid. So weak acid. And here we have to notice that BRO. Remember, lithium are always 1A in the column, are always spectator, so they're really irrelevant, so we can honestly cross it out. So Br BRO and HBRO. You can notice that these are conjugates. These are weak base, weak acid conjugates. And when it's weak and weak, what do? Henderson-Hasselbalch. So what we can first do is find moles. So 0.1442 liters times 2.66 for BRO, and for BRO minus, it is 0.0121 times 1.03. So let's find those moles. 0.1442 times 2.66, 0.384 moles, and 0.0121 times 1.03, we get 0.0125 moles. Now, in order to use Henderson-Hasselbalch, which is this, it is negative log of Ka plus log of base over acid. In this, what do we see? We have a Ka. What do we not have? A Ka. What do? Convert to a Ka. So how do we do that? Really simple. 10 to the negative 14 divided by whatever that is, 4.03 times 10 to the negative 6. What do we get as our Ka? 10 to the negative 14 divided by 4.03 times 10 to the negative 6. We get 2.48 times 10 to the negative 9. So let's plug that into Henderson-Hasselbalch. pH equals negative log 2.48 times 10 to the negative 9 plus log of base, which is BRO minus, so 0.384 over acid, which is 0.0125. Now, plug that all into the equation, into the calculator. So negative log 2.48 times 10 to the negative 9 plus log of 0.384 over 0.0125. And our, it is 10.1. That is our pH. And boom, that is how you do the quiz questions.